everyone, this is Allison, Steph, and Sam working on problem number 1 from worksheet 6. Our problem said that if f is continuous on the interval a to b, then f is integrable on that interval a to b. We want to show that for all epsilon greater than 0, there is a sum partition such that the upper sum minus the lower sum is going to be less than epsilon. So we started our proof by saying for all epsilon sub 1 greater than 0, there is a sum delta greater than 0, such that 0 is less than the distance of s minus t, which is less than delta. That's going to imply that the distance of f sub s minus f sub t is going to be less than epsilon sub 2. Now we're going to set this epsilon sub 2 equal to epsilon sub 1 over alpha b minus alpha a. And the reason that we're doing this is that eventually when we do our substitution, that denominator alpha b minus alpha a is going to cancel out, leaving us with just epsilon. Now we know that alpha is increasing, so that means that our epsilon sub 2 is going to be greater than 0. So we start off with a few definitions. We know that the upper sum is equal to that sum of capital M sub I delta alpha sub I, where capitalized M is equal to the sup of f of x over that partition. We know that the lower sum is equal to the sum of lowercase m sub I delta alpha sub I, where lowercase m sub I is equal to the imp of f of x. We also know that the sum of our delta alpha sub I is equal to the sum of alpha x sub I minus alpha x sub I minus 1 because we're increasing, which then is going to be over our interval of alpha b minus alpha a. The last thing that we know is that capitalized letter m sub I minus lowercase m sub I is going to be equal to that distance of f of s minus f sub t, which is going to be less than our epsilon, which we set as epsilon sub 1 over alpha b minus alpha a. So what we're going to do is that we're going to plug these values in to our upper sum and our lower sum and show that it's going to be less than epsilon. I'm going to change the slide. So how we're going to start here? We're going to say that our upper sum minus our lower sum and replace that with the definition that we had on the previous slide, where it's the sum of capital M sub I over times our delta alpha sub I minus the lower sum, which is the lowercase m sub I, times our lowercase m sub I delta alpha. Now, because capital m sub I and our lowercase m sub I are going to be fixed numbers, I can factor them out before the sum. So I'm left with the m sub I minus lowercase m sub I, the sum of delta alpha. From there, because I know that it is increasing, I can replace this delta alpha sub I with alpha x sub 1 minus alpha x sub I minus 1. Now I also can then replace this with my interval from alpha sub b minus alpha sub a. Now I can then say that it's going to be less than my epsilon sub 1 over alpha b minus alpha a times the alpha b minus alpha a. At this point, because we set that epsilon sub 2, the alpha b minus alpha a cancel out, leaving me with just epsilon. So then we showed that the upper sum minus the lower sum is going to be less than our epsilon. So from there, we have f is uniformly continuous on that interval from a to b, which then proves our problem, which says that f is integrable on the interval a to b. Hopefully that was helpful, and I'll enjoy your extra week off.